Alright, welcome to the next concept called parametric equations. This is probably the first time that you have encountered this type of concept if you never done things like Math Olympiad or whatsoever. But it's perfectly fine, right? Parametric equations, they can be a little bit tricky at the start, but the more practice you do it, the more naturally it comes to it. Okay, so let me just explain what this concept is all about first, and then we will show you how it's being applied in typical questions. So typical equation, right? A typical equation is one where you have two variables that are directly linked to each other. For example, y equals to x minus 1, right? Over here, we have two different variables linked by one equation, right? This is a very typical relationship, right? We have a direct relationship between these two. Now, a parametric equation is one where the two variables are linked together indirectly. In other words, they have an indirect relationship. So for instance, I can have an equation, so I'm just going to write here, right, is one where the two variables have an indirect relationship. So for instance, I can say that x equals to t plus 1 and y equals to t squared. So you can see that x is related to t and y is related to t, right? And when t increases or decreases, the x and y values will change accordingly. In other words, if I were to draw a sort of like a relationship diagram, right, the t value over here, it affects both the x and the y values, x and y values. So these x and y values, they are not directly linked to one another, but instead both values are controlled by a central variable called the parametric variable, right? So this is our parametric variable. You can think of it that way. So I will just draw a simple table over here to illustrate to you. Okay, so let's say I have a table over here, and let's say this is my t, x, and y. So t will have its own independent set of values, right? t0, t1, t2, and t3. So when t is 0, we get x is 1, and this will be 0. Right? When t is 1, we get x is 2, and then here will be 1. When t is 2, here will be 3, and here would be 4. And then when t is 3, here will be 4, and then here this will be 9. Right, so in the end, we get, when we actually sketch the curve of y and x, note that when we sketch the curve, right, we don't actually sketch the t. So I'm just going to scroll down here for you to see. In a parametric equation on the Cartesian plane, when we sketch it, we will only sketch the x and the y variable. But we know that what actually drives the relationship between these two in the back end is actually the parametric term, right, which is the t value. So over here, when x is 1, then y would be 0. So, it starts here, right? And then the whole equation just goes up like that. This is the parametric relationship between x and y. So this graph over here, right, to sketch a parametric equation. So what will be given to you in the exam would be just these two, right? You'll just be given these two, and in order to sketch a parametric equation like that in the exams, you have to use the GC, right, which I will be showing you subsequently how to use the GC. So this is one very common question that we will be asked to solve, right? And another very common type of question that we'll be asked to solve is deriving the Cartesian equation from the parametric equation. So I give you an example over here, right? Let's say x is t plus 1 and y is t squared. So to derive the Cartesian equation, which is the direct relationship equation that links x and y, the whole idea behind this is that we have to get rid of the t variable, right? We have to get rid of the t variable in that sense. So the way that you get rid of the t variable, it varies between different kinds of equation, right? If this is an exponential equation, a logarithmic equation, my approach will be slightly different for each case, right? But for this case over here, it's a bit more straightforward. For this case, I can write the first equation here as x minus 1 equals to t, right? And then I sub this one into here, and I get that y equals to x minus 1 squared. Right, so this over here fundamentally is the same graph as this, right? So this graph over here can be represented by both the Cartesian equation as well as the parametric equation. But what we have just done is that we have just converted the parametric equation into the Cartesian equation, which is another skill that you will keep practicing under this section of parametric equations as well. Okay, so feel free to pause this video and rewatch this as many times as you need, because from here onwards, there's no more other new concepts for this concept, and we'll just keep practicing in the next questions ahead. Okay, so let's use this question over here as an example to sketch the parametric curve. And once again, I'm going to be using my GC over here to show you how it's being done. Okay, now for starters, we need to first change the mode of our GC to parametric. So I'll go down to parametric, I'll click enter, and then I will go back. So now if you click here, you'll see that you have x1, y1. And that is where you will key in this, right? So I'm going to key this into my GC over here. So this would be t, let me just check one more time, t plus 2, t plus 1. So t plus 2, t plus 2, and then t plus 1. So here will be t plus 1. And then for the bottom equation, it will be 2t plus 1. 2t plus 1. Graph it out. And this is how the graph essentially kind of looks like, right? But before that, make sure that this t minimum is set as well. So we need to make sure that the range is big enough, okay? So when I sketch it, you see, so that's the challenge. If you did not adjust this to 0, then the graph will only be reflected from here onwards. So you must always make sure to check that you have your range here at least big enough, right? Reasonably big enough. Don't need to be like negative 100, but reasonably big enough will do. So now when we sketch the graph, we can see that it looks like that, right? So come back to here. When we sketch the graph, it will look something like that, right? Let's say here's y, here's x, and then when I sketch the graph, it should look something like this, right? A bit more like that, right? Whereby here is a critical point, and then here is a critical point. Now note that if we want to find the equation over here, so let's say I trace it, we see that in order to find the intercept over here, we cannot just directly find the intercept, right? Because you see that if we click 1 over here, we don't know what is the specific t value over here, right? And neither do we know what's the specific t value over here. So we cannot just key a random t value to give us the value of the x and the y intercept. So in order to do that, we need to manually calculate ourselves over here. Okay, and how we do that is to find the x and y intercept, we need to do it manually. So that's just a check for yourself. So to find the x-intercept, I let y be 0. I get that 2t plus 1 is 0. T is negative half. I sub t as negative half into the equation into x, and I get that x would be negative half plus 2, negative half plus 1, and in the end I get a value of 1/4. Right? So the first coordinate that I get from here would be my x-intercept. So my x-intercept over here would be 1/4, 0. So this is 1/4, 0. Right? Note that I still need to find the y-intercept after this. For my y-intercept, to find y-intercept over here, I must let x be 0. I get that t plus 2, t plus 1 is 0. So I get t is minus 2. Oops. Or t is minus 1. I sub it into the y value. I get that y is 2 times negative 2 plus 1, so I get negative 3, or y is 2 times negative 1 plus 1, which I get as negative 1. So I get two different x-intercepts essentially. I get negative 0, negative 1, or 0, negative 3. So I just need to sub them back here, right? 0, negative 1, 0, negative 3. And to find the turning point over here, this turning point over here will be in the middle of the two. So I know that here will be something negative 1.5, right? Because it will be in the middle of the two intercepts over here. So from there, I just need to find out what is the t value that gives me y equals to negative 1.5, right? So for this case over here, y is negative 1.5, 2t plus 1 is negative 1.5, 2t is negative 2.5, t is negative 2.5, divided by 2, and I get negative 1.25. Right, then I sub t as negative 1.25 into my x value, and I get that x is negative 1.25 plus 2, negative 1.25 plus 1. And overall, I will get a value of, let me just check. So here will be answer plus 2, answer plus 1, value of negative 3/16. Right, so here will be negative 3/16. And that's the final answer to this question over here, right, the first part. Next portion, we need to find the Cartesian equation, which is what I mentioned earlier. So the Cartesian equation would be to eliminate one variable first, right? And over here, we get that x equals to t plus 2, t plus 1. And we get that y equals to 2t plus 1. So obviously, it'll be easier to work around with this equation over here, right? Because we can just directly express t in terms of y, or y in terms of t, right? So we can make t the subject. So I get 2t equals to y minus 1. T is half y minus half, right? Half y minus half. And then from here, I can sub this equation back into here. Okay, apologies, it's a little bit messy, but essentially I'll get x equals to negative half y minus half plus 2, and I get negative half y minus half plus 1, right? And then from here, when you start to expand this and start to simplify the whole equation, eventually your answer should be 4x equals to y squared plus 4y plus 3 as the final answer to this question over here. Okay, so I'll leave the expansion part up to you. As a JC H2M student, this should be of no problem to you. Okay, otherwise, this is the main skills required for parametric equation, and I've gone through the two most important skills needed. Hopefully, it was helpful for you, and try out other questions to practice this skill for yourself. And if you have any other questions, feel free to reach out to me through WhatsApp. If not, thanks for watching, and I'll see you in the next video.